All right, guys, so before we get started, are there any questions over any of the assignments thus far? Or any questions over the homework assignment last night? Nothing that y'all can think of at the moment? All right. Because again, at the beginning of each lesson, we'll go over a few of the homework questions. So if you have questions on them or want to see one of them worked, I can work it through it. I'll work it through it with y'all. Now, if there aren't any questions, we'll go on and look at the problems today. All right. Now, the ones we'll look at today are really it's going to be probably today and tomorrow at least. Is just solving equations. And the first ones we'll look at, these here are going to be pretty straightforward, are going to be solving linear equations. Now, probably you already know the answer to this one, because if we're going to solve this linear equation, whenever we have an equation where the degree is when it's linear, and we just want to get x by itself. So the first thing we can do here is going to be, well, add 6 to both sides. After we add 6 to both sides, it'll tell us that 3x is equal to 6. So we would divide by 3 minus x is equal to 2. And that's it. That's all we would need to do for this one here. Any questions on this here? Do we need to see really any more solving linear equations? So do we feel comfortable with doing stuff like this here? Yes. If so, we'll go on and move on to this one here. Now, even though this does involve fractions, it's still considered to be it's a rational equation, but it's kind of nice because we don't have variables in the denominator, the bottom of the fraction. Out of the way. Now, one thing that is handy when working with fractions, or a handy, not what's handy, what is a handy tip with working with most fractions, decimals, anything like that, is using a least common denominator. We're going to multiply the entire equation by a term, a number or a variable or both, to get it to simplify. Because if I can multiply the x over 3, 3x over 4 by a single number and get that to go away, it's going to make it easier to work with. Now, whenever we're dealing with decimals, say 3.7x squared going on, really, however many decimal places we have, we can multiply it by a set number of tens. So if 3.7, there's only one decimal place across all of them, we can multiply the whole equation by 10. If one of them has, we have 3.7815, there are 4 decimal places, we can multiply the whole equation by 1,000 to get the decimals to go away, because then we're dealing with whole numbers, because for the most part, we like dealing with whole number answers instead of decimals or fractions. And looking at this here, so we're looking at 3 and 4 because that's the ones we want to get rid of, yes? What is the first number that I can turn both 3 and 4 into? What would it be? 12, yes? Because that's the smallest number I can turn both 3 and 4 into. So if we use that fact, and I multiply everything in this equation by 12, it's going to make this simpler. It's going to make it easier to work with. Because what we have here is we multiply on top, so we would really have 12 times x over 3. plus 12 times 3x over 4 is equal to, well, 2 times 12 is 24. Now, a lot of times we would go on and just cross out on the first step, because I could look up here and say, okay, 12 over 4 would reduce to 3. 12 over 3 would reduce to 4. We can write it out down here and say, okay, that simplifies to 1. This simplifies to 4. This simplifies to 1. This simplifies to 3. We could have done that in the original step or in the first step, but if it's helpful to write it back out, that works too. Because really what this is telling us is that our first expression is now just 4x plus the second one we're left with 3 times 3x, and 3 times 3x is 9x is equal to 24. Now we need to add them together. So 4x plus 9x is 13x is equal to 24. And last but not least, we would divide. Divide both sides by 13. Telling us that x is 24/13. Not a great number, but it is what it is. Any questions on this so far? Yep, 24/13. Not too bad. So any other questions on this here before we move on to the next one? Okay. So looking at this one here, we want to solve for the value of x. What can we do first? Huh? Add 1/3? Yeah, we could add 1/3 to both sides. That would work just fine. And it does work out nicely, because on the left-hand side, we would have 4x over 9 is equal to, because negative 1/3 plus 1/3 is 0, is equal to x plus 1/3 plus 5/3 is 6/3, which would reduce to 2. Now what can we do? We do have that pesky 4/9, don't we? Is there a way that I can reduce that down or get rid of the fraction? Yeah, we can multiply it by 9. Because I can multiply this by 9. Well, we got to multiply everything by 9. But it's nice because here the 9 and 9 will cancel. We could have done it just like I did in the first one and rewrote it down below as 9 times 4x over 9. But here we know that they cancel out completely, leaving me with just 4x is equal to 9 times x is plus 18. Now we're just back to a linear equation. And we can minus 9x from both sides. 4x minus 9x is negative equal to 18. Which means last but not least, we're going to divide both sides by negative 5 telling us x is equal to negative 18 fifths. Yep. And we get this here. What we can do if we want to is check these. If we want to check it to make sure that we got the correct answer, because sometimes, especially looking at this, negative 18 fifths seems like a really weird answer. So what we can do is plug it into the calculator. Now, the nice thing with the TI-84 Plus, okay. Okay. Apparently, we can type it in. There's a chance I'll have to figure this out eventually. Yep. Okay, there we go. Now it's working. Yep. Okay. We can type the whole thing in. Now, one of the other things, so for those who've had me, I don't know if all of y'all have used one of the graphing calculators, we can type the answer in. So what we can do is use the store feature. Now alpha y equals enter will give us a fraction. Now the answer that we had was negative 18 over 5. So that's the answer we got, yes? And what we can tell the calculator to do is store that in for a variable. So store down here, STO, X. Okay, I'll figure that out later. Enter. So what this has done is it told the calculator that the value of X, until we change it, is going to be negative 18 fifths, which is the answer we got, yes? Now what we can do is take the equation that we have, so alpha y equals enter, and say 4x over 9 minus alpha y equals enter 1/3, and we can see what we get here. So I can go on and hit enter. So I get negative 29 fifths. Yes? So that's one side of it. That doesn't tell us the whole thing yet, because the other side of the equation was x plus 5/3, yes? So I can do that also. I can say x plus alpha y equals enter 5/3. Now, if both sides of the equation give us the exact same thing, it means that x is indeed negative 18 fifths. They both give us the same result, so that is the correct answer. Does that make sense? Now, we could have done a little bit of a shortcut to this here, because you could type this in, and then I could say minus parentheses x plus alpha y equals enter 5/3. And all I did was what? I took the one side of the equation and subtracted it from the other. So if these are the same, both sides are equal, this should give me what? 0. Yeah. So there's just different ways to check the answer. So you don't have to do it by hand, because the calculator will check it to make sure we did get indeed the correct solution. Questions on any of this so far? A lot of recap from what y'all did last year. Some of this, we didn't do too many equations with fractions, but it is a similar process. All right, so we're going to look at this one next. So this one here is indeed a rational equation, because this is going to be the first one where we have variables in the denominator, the bottom of the fraction. Now, when we work with these here, it's going to be similar to what we just did or some of the previous ones. We want to multiply by a least common denominator for one to get rid of the fractions, and 2 so that we don't have variables in the bottom. It's going to be easier to work with. Now, one of the ones that we know for sure that we're going to multiply everything by is going to be x minus 2 and x plus 2. And the reason we know that is because one of these here, the highlighter, because the first one here has x minus 2. This one here has x plus 2, so we know we'll need those two for sure. And the other one that we have is x squared minus 4. Now we would include that as long as, one, this isn't factorable. Because if x squared minus 4 is not factorable, we'll need it because it can't be represented as any other terms. But is x squared minus 4 factorable? Well, yes. It is a difference of perfect squares. Because when we look at this here and we have two terms, x squared is a perfect square. X times x would give us x squared. What times itself would give us 4? 2. So this here is a difference of perfect squares. Now, our definition of difference of perfect squares is a squared minus b squared is equal to a plus b times a minus b. This is just the difference of perfect squares. So we could go through factoring it to see that this here actually works out to be x minus 2 times x plus 2. Any questions on how we got this factored? Now, a lot of times when I will work on these here, instead of rewriting the whole thing over, because a lot of times, especially in Algebra 2, I would rewrite the entire thing just to make this one factor. But what we can do instead is do that and then mark that one out. We mark it out just as a way to tell ourselves we are not working with x squared minus 4 anymore. It is now x minus 2 times x plus 2. I like this. I like doing this here mainly because it saves us a little bit of work. We don't have to rewrite the entire equation just to change one term. Now again, when we look at least common denominator, we're wanting to multiply everything by something so that the denominators simplify out completely. Now there are different ways to check it and see if it works. But one of the things we can do is almost kind of a guess, not a guess and check, just a check method. So what we can do is say x minus 2. I'm going to multiply everything just by x minus 2. And then we can cross it out and see, do we still have denominators or do we not? Because if we multiply everything by x minus 2, the first expression, well, the x minus 2 and x minus 2 would cancel because they would be on top and bottom, and anything divided by itself is 1, so they would simplify out. If we look at the middle term, well, this x minus 2 and x plus 2 won't simplify. They're not the same. And in the last one, well, this x minus 2 and this x minus 2 would cancel, and we've simplified each of the terms, yes, with the x minus 2. Do we still have denominators? Yes, okay. Well, I have an x plus 2 that I still need to get rid of, yes? Okay, so we can add that in. X plus 2, x plus 2, and again, we have to add it into all of them. Okay, here, x plus 2, x plus 2. Here, x plus 2, x plus 2. Do we have any denominators left? No. So we know we have everything. So again, I could have started off with x minus 2 and x plus 2 and used both of those across all three and try to see if everything canceled out. If it does, awesome, we're good, we can move on. If not, then we need to add whatever is still left in the denominator across all three or across all of them and simplify it out that way. Now the reason this is helpful, because it seems a little tedious, probably, is that it prevents us from adding too many. Because each one of these terms that we add on top is going to increase the degree of whatever equation we're going to solve. So if we look at this here, if we multiply through 1 times x plus 2, there's going to be x plus 2, equals 3 times x minus 2, minus 6x. And as we look at each one of these terms, the biggest exponent with any of the variables is going to be 1. Because there's no spot in here, even though we haven't multiplied through yet, where x is being multiplied by another x. Because the first one is just going to be x plus 2. The middle one is still going to have, this is x plus 2. If we multiply through, 3 times x is 3x. 3 times negative 2 is going to be negative 6 minus 6x. So in any of these places here, the biggest exponent with a variable or attached to the variable is 1. So we just have a linear equation, yes? So if I would have added an extra, if I'd have added the x squared minus 4, that would have taken this from a degree 1 to a degree 3. That means we would have had a variable, an x cubed, x to the 3rd power. Because each time we add an extra one in multiplication, this multiplication step is going to increase this degree equally to that amount and provide us with extraneous solutions, solutions that don't work in the original problem. Now at this point here, we can go on and solve. We can combine like terms. On the left-hand side, we don't have any like terms. On the right-hand side, we have 3x minus 6x, which would be negative 3x minus 6. What do we want to do next? We can subtract x from both sides. So we're going to be moving the x's from the left side to the right side. Then we would need to do what? Move the numbers from the right side to the left, yes? And most classrooms, and I do this too, we normally write this in 2 steps, yes? If we feel comfortable, if y'all feel comfortable doing it in a single step, that's fine. We can do this all at once because we can move left and right. Because on the left-hand side, the x's will cancel out. 2 plus 6 is 8. Is equal to negative 3x minus x is negative 4x. Negative 6 plus 6, that cancels out. So that leaves us with 8 is equal to negative 4. And last but not least, we would divide by negative 4, telling us x is equal to negative 2. Any questions on this here? We good with this here so far? All right. Now with these here, we do have to be careful of extraneous solutions. Because again, we can't divide by 0. So anything that will make the denominator 0 is not going to be a solution that works. So we look at this here, the spots that we're trying to look at to see if we get an extraneous solution are going to be here, here, and here. And really in all 3 of these places, we're either dealing with x plus 2 or x minus 2. So, what would make x minus 2 be 0? What would that be? 2. What would make x plus 2 be 0? Negative 2. Yeah, because what we could do is just say x minus 2 is equal to 0. Add 2, add 2. Same thing with x minus 2. Or x plus 2. It would be minus 2, minus 2. So x can't be 2 or negative 2, because if it is, it will make one of the denominators be 0, and it doesn't work. Okay, that's kind of nice to know. Luckily, well, unfortunately, our one answer that we got was negative 2. X cannot be negative 2, so this is actually a no solution. And that's what's frustrating with some of these here, because we can do all the work, get down to the answer, and realize, okay, it never worked in the beginning. Any questions on this here? All right. Let's look at the next one. So this one here, again, I gave us a few more of these here because they're a little bit harder than the stuff we've done, than the other ones that we've solved so far. So we'll look at this here. And again, we're looking for a least common denominator, something to multiply this through by to make it easier to solve. So we need to find something that we need to multiply everything by so that we get the denominators to cancel. Well, there is one thing that we know for sure that we're going to need to multiply by, which is r minus 2. That's going to be for sure. Now, hopefully we'll have a few more things because the middle term is going to need to simplify. I don't know about y'all. Do you guys like this, writing it underneath instead of having to rewrite the whole thing over again? I find it a little bit easier. Now, we need to factor this here, r squared minus 7r plus 10. We need to factor it down. Now, what would be nice, a nice factor that comes out of this here? R minus 2. Because if one of these is r minus 2, that means I have one less thing I'm going to multiply everything by. So it would be nice if we did have an r minus 2. Because if it was, that would make everything work a little bit nicer and have less terms to multiply by. Now, for some of y'all, it's been a while since we've factored or gone through the way that I'd go about factoring. I don't know how you learned it. But the way that I've always done factoring, and I'll write this on the sideboard, is the first main step is going to be to find a greatest common factor. If there is one, that's what we find. And here we don't have one. So step 2 is 2 sets of parentheses with 3 spaces. That's just a spacing thing. Because we know that we'll have 3 terms or 3 things in each one because we'll have 2 terms and a sign. Now, the one that I find interesting or kind of helpful is figuring out the sign first. So if third term positive, signs same, and match the middle term. If third term negative, opposite signs. And the reason that this works out so well is because, again, when we factor or multiply back through, these signs determine what the middle one is. Because when we multiply through, where we get the middle term is from these two here. So if it works out, okay, sorry, I'm getting ahead of myself. So the way that we get the last term, the third term, is really just from these two here, the two constants being multiplied together. Well, the only way that we can get a positive number is if they're both negative or both positive. That's the only way it works. So if the third term is positive, it means the signs for these here are both negative or both positive. Yes? Now, the way that we get the middle term is the ones in green where those multiply out. Well, if the signs are the same, that means whatever this sign gives us and this sign gives us will be the sign of the middle term. So it's kind of a hint to say, okay, what is the sign going to be? That way, where some methods end up looking at all the different sign factors that we could possibly have and going from there. So from this here, because the 10 is positive, we know the sign should be the same. And because the 7r is negative, it's already telling me they both have to be negative. So I find this a little bit easier to use, but if you have a way that works better for you, use it. You don't have to stick with this one. Now the fourth step is to look at the factors of the first and third term. And luckily, the easiest one out of these two is r squared. Well, the only thing that multiplies together to give me r squared is r and r. We only have one set. Now, the factors for 10, we have 1 and 10 or 2 and 5. So if we want the one to be r minus 2, we'll have to use 2 and 5. And it indeed does work out that these are the factors. So we do have it factored out. We could check it if we want. And I have a feeling when they had you check it, probably in Algebra 2 or 1, they want you to multiply the whole thing out. Or, I mean, so if I checked it, it would be r times r, which is r squared. Then we do r times negative 5, which would be negative 5r. Negative 2 times r is negative 2r. And negative 2 times negative 5 is plus 10. Then we subtract. We get this here. It's the same as what we started. And we have this here. Yes? I have a feeling that's what they probably did. I don't like that method. Well, it's not that I don't like it, and there's nothing wrong with it. Where did we get r and r from? So when they multiplied it back together, I should end up back with r squared. So is there any real reason to do that? No, no reason to do that. Where did I get 2 and 5 from? I got them from the factors of 10. So they should multiply back together to give me 10. Because the only thing I'm really focused on is the middle term. So why not just multiply the ones that give us the middle term, focus on those, the ones that do change, and leave the rest out. That's just me. Because if something's not necessary, especially at this point, y'all understand you guys have a good founding in mathematics. We don't need these extra steps. They're here to help us to see where everything's coming from. Y'all know where it's coming from. You don't need to do it. All right? Makes sense? Okay. Now, I always have a tendency to forget to do this, and if y'all do, especially with working them, that's fine, is also looking at the restrictions. Because you can do this after you finish solving, or you can do it before we start. Either one works fine. It's just seeing what's going to make the denominator be 0. Well, with the 3r minus 2s, we know r cannot be 2. Because 2 minus 2 would give us 0. We can't have it in the denominator. What other number can we not have? 5. Because 5 minus 5 would give us 0. So it doesn't work. So now we know if 2 or 5 shows up as an answer, they don't work. All right. Now let's make this a little bit easier to solve. So we'll multiply everything by r minus 2 and r minus 5. All right. So let's see what cancels out. Now in the first one here, r minus 2 and r minus 2 would cancel. In the middle one, well, r minus 2 and r minus 5 cancel. And in the last one, r minus 2 and r minus 2 cancel. And again, we kind of have a nice one here to work with. Because when we rewrite this in the first expression, we're left with r minus 5 plus 1. Because what we multiplied, the r minus 2 and r minus 5, canceled out with the entire denominator, and the only thing left in the numerator worked out to be 1. Make that look like a 1 and not 11. Equals, well, we have 6 times r minus 5, yes? And in a lot of classes, again, we could so you don't have to write this down immediately. We could write this as 6 times r minus 5. There's nothing wrong with that. But that, for me, that's not how I would go about doing it. Because what is 6 times r? What's 6 times negative 5? Might as well. I mean, if we can do it, and you know, because again, this is all on y'all. If you feel comfortable going on and multiplying it, go on and multiply. Because if we don't have to keep rewriting these things, might as well not. All right. Because if we wanted to, we could have combined those negative 5 and 1. Because negative 5 plus 1 is negative 4. Well, now we need to move things to the left and right to get r by itself and the numbers on the other side. Personally, I would subtract r from both sides. And then we can also add 30. Because we're moving the variables to one side, the numbers to the other. Because here, r minus r is 0. Negative 4 plus 30 is going to be 26 is equal to 6r minus r, 5r. 30 minus 30 is 0. And last but not least, we would divide both sides by 5, telling us r is equal to 26 over 5. Was that one of our restrictions? Nope. So that's it. Any questions over any of this here? Oh, that's where I got that one from. All right. Before we get to that, so do we feel pretty comfortable with these here, with these rational expressions, getting to see them again? Because I think for a few of y'all, it's been more than just a summer since y'all have covered a lot of this. Okay. We're going to stop there because I realize we're getting close to time. I know we've got about 6 or 7 minutes, but that's fine. All right. So that's where we'll stop for today.